Let's go to question 2. Figure 2.1 shows a man pushing a box of mass 20 kg. So underline this. This is the mass across a horizontal floor at a constant speed. Now, if it's a constant speed, do take note, it means that acceleration is equals to 0 meter per second squared. Okay, or 2.0 meter per second. The box slides without tipping. He pushes the box by applying a constant horizontal force. So he is pushing the box at 80 Newton. Okay, now part A. Part A is relatively simple. It says calculate the weight of the box. So to calculate weight, we know the formula is W equals to mg. So G is the gravitational field strength on Earth. Mass, we know there's 20 kg over there, so it's 20 multiplied by 10, answer will be 200 Newton. Okay, so the first one is 200 Newton, simple 2 marks. Now the next part, state the size of the frictional force on the box and explains how we obtain the answer. So now let's start by explaining this first. We know that based on question, acceleration equals to 0 meter per second. Hence, using F equals to ma, the resultant force is 0 Newton, as he is pushing the box at 80 Newton, comma, the frictional force must be 80 Newton in the opposite direction from the pushing force. So the direction will be, if the guy is pushing towards the right, the direction of frictional force will be towards the left. Okay, relatively simple now. Now let's go on to the next part. It says the box then moves onto the polished section on the floor in figure 2.1. As he continues to apply the same force, so this is 80 Newton now, okay, the box accelerated at 1.5 meter per second square. Calculate for the box on the polished section of the floor the force causing the acceleration. So we know that now the acceleration is 1.5 meter per second square. We know that the mass of the box is 20 kg, so we can actually find the force. So we use F equals to ma, and this force is actually the resultant force. Do take note, every time when we use F equals to ma, we are finding the resultant force. So this is equals to 20 multiplied by 1.5. So this will be equivalent to 30 Newton. So the force here is 30 Newton. Now, what will be the size of the frictional force over here? So if the resultant force is equals to 30 Newton, we know that the pushing force is equals to 80 Newton. Therefore, we know the frictional force must be equals to 80 minus 30. The pushing force minus the resultant, what you're going to get is 50 Newton. Okay, so we're going to have 50 Newton over there. So that's for question 2.